What's up? What's up? What's up? It's your boy, the network. And today's topic is subsection 2.2b, point to point, which is a subsection of section 2.2, explain frame relay. This is a topic in the CCNP route exam code 300-101, version 2.0. Again, make sure you are studying for the correct version. These exams retire. They get renewed with new material, so make sure you're studying for the correct version. Shout out to your boy again, Duan, Lightfoot, lab every day. This is what we do. We lab every day. Again, this is a community that's online. This is something that we try to do and during these topics in our mind. Another shout out to Professor Graziani out of Cabrillo College. I used some of his slides in this video. Check him out. I loved his teaching style. And I ran his material online a lot, so I decided to use some of his slides in this video. All right, moving right along. Let's look at the exam blueprint and see where we came from and where we are going. That instrumental was Master Ace, the grind, because we are on our grind and we are labbing every day. That's what we try to do, lab every day, because we are on our grind. All right, again, exam code 300-101, implementing Cisco IP routing. We just wrapped up explain frame relay 2.2a, operations, frame relay operations. We did a basic frame relay setup in Packet Tracer, and we're going to run Packet Tracer again. Like I said, it's just simpler to run on Packet Tracer. Some commands are not supported, some are. The ones we really need to know are definitely on Packet Tracer, but if you want to get a little further, you definitely want to run it in GNS3. I may run some bonus labs and put up videos on that, but I'm going to be doing all that in my own if I don't have time to, upload these videos. Again, these videos for my own purposes, but I decided to share it with the world. Today, we're going to be doing point-to-point, section 2.2b. After that, we're going to be doing the next video, multi-point. So, frame relay, again, is a layer 2 encapsulation solution that is used on the wide area network, right? Normally on the wide area network, you're using IP, which is layer 3 technology, using IP addresses and stuff. But with frame relay, we are using delcies, what's called delcies. It's a 10-bit value that is a layer 2 address. It's kind of like a MAC address, and we map that to a layer 3 address, which is an IP address, and that's how we kind of communicate with through a frame relay network. So let's talk about what the difference between point-to-point and multi-point is, right? Point-to-point is basically what it is. It's just one node connected to one node. It's called a point-to-point network. One point on one network, right? As opposed to multi-point, one point and multiple points. I'll show you on this next slide here. This is a basic topology of a point-to-point network right here on the left-hand side versus a point-to-multi-point, which we're going to be doing tomorrow or the next video, whenever you're watching these videos. So the thing is with these topologies that you're seeing here, they are directly connected to each other, as opposed to in a frame relay network, they are connected in a cloud, right? So you've got this is a point to a multi-point in a frame relay cloud with a frame relay switch in the middle. That is basically the cloud. We don't know what's going on. They know, we just know our service provider connected headquarters to branch router 1 and branch router 2. They're not directly connected with one long ass cable or anything. We just have what's called a PVC, permanent virtual circuit. This is a virtual connection. So these are, we just needed to explain the difference between, the point of this slide is to explain the difference between a point-to-point versus a point-to-multi-point. So these are directly connected right here. But with frame relay, we have a cloud in the middle of these. And we just have a virtual circuit connecting all of these guys. So router 3 to router 6, router 3 to router 5, etc. So this is what our frame relay network really looks like. They are connected with PVCs, a permanent virtual circuit. Sometimes they are done with a SVC. They are just brought up temporarily in case you need to, like, say you have a remote worker and you just need to connect, you just need to send data temporarily, and it's brought back down. But normally a service provider sells PVCs, which are permanent virtual circuits. So this is the official definition. We've talked about this in the previous video, but we'll do this again. industry standard switch data link layer protocol, so layer 2, but we use it on a wide area network that handles multiple virtual circuits. So multiple, these guys right here, these red lines, using HDLC encapsulation between connected devices, right? HDLC is the default encapsulation for Cisco devices. The other type of encapsulation is what we're doing right now, frame relay. Frame relay is more efficient than X25, which was the predecessor. The protocol for which it was is considered a replacement. Now, these are some of the commands we're gonna go over. I said I was gonna go over them in the last video, but I'm gonna make sure we go over them today. They're just 3 show commands, and then we're gonna be mapping a sub interface instead of just a physical interface. We're gonna be bringing up the physical interface, but below it we're gonna have sub interfaces, and we're gonna connect point to point connections to them. To the next video, we're gonna be doing point to multi-point. Now, the thing with frame relay point-to-point connections, the reason why we need to create sub-interfaces is because of, number one, the main reason why is because of routing updates that we are expecting to obtain from OSPF or EIGRP, right? Hello messages and routing updates, right? Now, the thing with routing updates, we receive them and then we send some back, right? But there's a thing called split horizon. If you remember from your CCNA studies, split horizon is a feature that prevents routing loops. You have a routing update or whatever traffic that comes in one interface, right? But we don't want to send that information back out the same interface because we'll create what's called a routing loop. Luckily, there's time to live and eventually it'll die, but we want to avoid that altogether. That's what split horizon is. Reachability issues are the issues that we can experience with routing updates. First, let's talk about what an Nbma is. It's a non-broadcast multiple access network, which means more than 2 nodes can connect to the network. So like in this case, we have a couple nodes here. This is really a point-to-point link, right? But let's say, for example, we have this routing update. This is like, let's say branch A got some other nodes connected to him. And he just received an OSPF routing update. Well, he need to send it to the central office, right? So he sends this update to the central office. But like I said, with split horizon prevents updates or information coming out of one interface and back out the same interface, right? So that's why this is one physical interface right here, right? So if we get this routing update coming in here, we don't want it coming back out of there because it's going to create a loop. It's going to create a loop. So that's why we got this big ass block right here to stop the loop from happening. So if you see right here, it says, however, in an Nbma, such as frame relay, nodes cannot see broadcasts of other nodes unless they are directly connected by a virtual circuit. So branch B is not directly connected to branch A. So if he sends him a routing update, if he sends the central office a routing update, it's going to stop right there. It's not going to come back out the same interface because split horizon. Now, one thing we could do, we could just turn off split horizon. In this example, there are problems with routing protocols because of the split horizon rule. So the split horizon rule prevents updates coming out of this because this is one interface. Split horizon says we don't want information coming into one interface back out the same interface. If we had an interface coming out of this way, we can send an update that way, but we don't. It's just going to come, it's a broadcast, so it's going to go out of this way, and we don't want that to happen, so we block that. We could either turn off split horizon, but then these guys are not going to get the updates. Branch B and C are not going to get the updates, right? So, and here's another slide that kind of explains that, right? We have a PC, or we have a router 3. Let's say he receives information from this PC. The PC sends it to router 3. Router 3 sends it to router 2, and he sends an update to router 1, and then router 1 gets the same exact information. He sends it out of his other interface, but it gets blocked from this guy because of split horizon. The rule says we don't want, otherwise if this wasn't blocked, then the loop, we'll just have a loop. We'll just have a loop. until it dies at 255 till the time to live exceeds, and then it drops. That's where time to live comes in handy. But we still don't want loops from happening. So we could turn off split horizon, or we could create subinterfaces. And that's where these guys come in, and that's what we're going to discuss today. And I'll show you that in Packet Tracer. So let's say branch A has a routing update, and he needs to send it to branch B and C, right? So he gets a routing update, some kind of OSPF from some other routers up here, or from another network, whatever. He sends it to the central office. He's going to send it back out to branch B and C, but notice how he's not sending them out of serial 00. This was one physical interface, right? Now he's created subinterfaces under serial 00. We've got serial 00.1, .2, .3. But this is a frame relay network, so he's got to map them to DELCs. If you don't remember what DELCs are, go in the last video. If you ain't got time for all that, let's discuss what DELCs are. DELCs is a data link identifier, data link connection identifier. It's a 10-bit value that acts as a layer 2 address that's mapped to the IP address. So therefore, we've got DELC 52 is mapped to the IP address. It ain't shown here because otherwise it'll look like a hot mess, and we don't want all that. Branch B has an IP address. So if he needs to send information to branch B, he's going to send it to his locally known DELC 52, which is mapped to an IP address that is assigned to a serial interface on branch B. Same thing with branch C. He needs to send information to branch C. He's going to send it to, because remember, he's not directly connected. We ain't showing it here, but let's just say this is a frame relay network. There's a frame relay cloud between these guys. He needs to send information to branch C. He's going to send it to his locally known DELC 53 out of subinterface serial 00.3, and he sends the update to branch C. So instead of turning off split horizon, which is something that we don't really want to do, especially if you got to manually do that for, every router, we just create subinterfaces, and every time we receive an update from branch A, or vice versa, we receive an update from branch C, it comes into serial 00.3. We need to send that update to these other two guys. We just going to send it to our locally known 51 and 52 and send updates to these guys, and vice versa. So now we have connectivity to all these guys, and it's transparent because there's really a frame relay cloud between these guys. We're not directly connected. This topology shows them directly connected because this is one line here. But theoretically speaking, let's say this is a free frame relay network. We have a cloud, a frame relay switch that's providing, our service provider, CenturyLink or Sprint or whatever, that gives us these DELCs, right? And then it just looks like one network. That's why it's called a cloud, because it's transparent to us. We don't care what's going on in there. Just connect us, because we were not directly connected. And that's what the service providers do for us. Luckily, when the CCNP exam, we don't have to discuss connectivity or configuring a ISP router. So let's see where we at here. 16 minutes. All right, so, and this allows each subinterface to act similar to a leased line. This is because each point-to-point subinterface is treated as a separate physical interface. So this looks like a physical interface. This will look like this will look like a point-to-point interface. This will look like a point-to-point link. And this will look like a point-to-point physical link, even though there's a frame relay cloud in between these guys. That's how we set it up with these subinterfaces. So, and this slide right here shows the difference between a multi-point. So we can discuss, or we can have a multi-point link by having serial 00.1, map it to that IP address, and DELC, we have a connection to this guy. Same thing with this guy. Here's a point-to-point link. One router, one router. This is a point-to-point link right here. But there's a frame relay cloud between these guys. We're just making it, it's kind of like an illusion of one connection here. Even though we're just doing that. It's kind of like we tricking these routers and thinking there's one physical connection here by putting these serial subinterfaces, IP address, and mapping it to a locally known DELC. Again, here's the difference between a point-to-point link that's physical and a point-to-point, point-to-multi-point link, right? This is how it would look like it was physically connected, when really we have a cloud in between these guys. And that's what the service provider is responsible for. Here's a little bit more frame relay terminology. If you want to, you can freeze frame this if you want. Pause it right here. Take a look at these definitions. Or you can go to the last video, and I discuss these definitions in detail. Let's go over LMIs again. Now, this will be shown to you in a frame, show frame relay LMI, I believe it is. Actually, yeah, show frame relay LMI. These are the different statuses for a PVC connection. Y'all remember what PVC was, right? This is a PVC, permanent virtual circuit. We use this to connect headquarters to branch router 1. Even though they're not physically connected, this virtual circuit right here makes it feel like we are connected, or gives us the illusion that we're connected, right? But we have statuses for these virtual connections. Active, let us know it's active. Inactive, basically indicates local connection to the frame relay switch is working but the router connection to the frame relay switch is not working, right? And then deleted, when there's no service between the CPE router, which is us, customer premises equipment, and the frame relay switch, which is owned by the ISP. That means it's deleted. And this is what, when we run the show frame relay LMI, we'll see the locally known DELC, whether it's active, inactive, or deleted, and then the sub interface, which we're going to configure. Let's go ahead and configure a point-to-point sub interface on Packet Tracer. All right, this is our IP addressing table right here. In part 1, we're going to configure frame relay. We've done this before, but we have to do that anyway. So in this activity, you will configure frame relay with 2 sub interfaces on each router to reach the other 2 routers. You will also configure EIGRP and verify end-to-end connectivity. So let's look at this topology right here. We have our PC, laptop, and web server. Here's the internet, and here's the frame relay cloud. You might as well say this is your ISP, kind of, that handles this stuff right here. This is locked. Well, actually, no, it's not locked, but we can't configure it. But anyways, so we're going to have 2 sub interfaces to connect to the laptop or to router 2. We're going to have 2 sub interfaces going to each way. Each one is going to have 2 sub interfaces. And we're going to have routing updates that's going to be able to go in and out from each other because of the sub interfaces. Let's go ahead and router 1, enable, configure, terminal. Interface serial 000. Back to router 1, encapsulation, frame, relay. Let's look at our different types of encapsulation. Do you remember what default was? HDLC. We've discussed this multiple times. There's also PPP, point-to-point protocol. HDLC is the default, and today we're doing frame relay, right? Encapsulation, frame relay. No shut, bring up the serial interface. Now our serial interface is up. Let's do a show IP interface brief to see what's going on here. Do show IP interface brief. Shout out to Tony E. 000. It's up right now, right? Let's do a show frame relay map to see what we got going on here, just so I don't forget this time. Control Z, show frame relay, no, LMI. We've got a couple status messages here. Our LMI type is Cisco right now. I think we're going to keep it at Cisco. Frame relay DTE. We got a couple messages being sent already. Let's refresh. A couple messages being sent real quick. Show frame relay map. Let's do a show frame relay, right? Map. These are our options right there. None. Why? We haven't mapped anything yet. Remember, we have to map the IP address to the DELC. That's what's going to show up in that. Okay, let's do a show frame relay PVC. Let's see what we got here. PVC status inactive, right? We haven't created any PVCs yet. Interface 00000. We've got some traffic coming in and out of our outputs. It could be some, I believe that's called controlled traffic, like CDP packets. Most likely it's controlled traffic. Del C 102, 103, unused, right? We're gonna create some Del Cs in the sub interfaces, and then we'll take a look at them. So right now we've got Del C 102 and 103, which I believe was created in the last video. So next thing we're gonna do is configure frame relay encapsulation on serial 000 interfaces of router 2 and router 3. So we're gonna configure frame relay encapsulation on router 2 and router 3. Let's go ahead and do that. We just did that right now. We're doing it for router 2 and router 3. Enable, configure terminal, interface serial 000, encapsulation frame relay. Again, do you remember the default encapsulation? Pause here. That's right, HDLC. I've asked you that multiple times. No shut to bring them up. Let's do the same thing to router 3. We are at 6 out of 100. Enable, configure, terminal, interface, serial 000. No, actually, let's do encapsulation, frame relay. You remember what default was? That's right, HDLC. I'm tired of asking y'all that. Y'all should remember by now since the last video. No shut to bring them up. We already know what sort of interfaces that are on here. But let's do it anyway. Do show IP interface brief. We've got our physical interface, gigabit. That's for the local area network. And then we've got the wide area network interface, 000. That's up. Same thing for the other 3 routers. Next thing we're going to do is test connectivity. We're going to test connectivity between the PC and laptop. So far, we've got 10% of this complete. PC. So right now, we're going to ping the PC. The PC is going to ping the laptop. PC is going to ping the laptop. What's the laptop's IP address? 192.168.30.10. Is it going to work? Destination host unreachable. Who did we receive that unreachable from? Do you remember? 10.1. So 192.168.10.1. That's the gigabit 00 interface of router 1. So we sent a packet trying to reach the laptop, and then this guy said, "Nah, I don't know how to get there." And he sent us an unreachable. You don't remember what unreachables are? Go to CCNP route playlist and look at unreachables. ICMP unreachables. Ping from PC to laptop should fail, which it did, because the router 1 router does not have a route to reach the 30.0 network. This is this guy right here. Router 1 must be configured with a frame relay on sub interfaces so that it can find the next hop destination to reach that network, which is what we're going to do. Each router, so configure frame relay point-to-point sub interfaces. So we're going to create sub interfaces to make it appear that router 1 has a direct line to router 2. That's what these sub interfaces are for. Configure router 1 to use sub interfaces. Del C 102 is used to communicate from router 1 to router 2. Let's go ahead and do that. Right? Let's bring up router 1. Enable, configure, terminal, interface, serial 000.2, and we're going to put, there's 2 types that you can put here after that. Multi-point, treat it as a multi-point link, or point-to-point. That's only the difference between the 2 videos. I might combine these 2 in the one video, multi-point and point-to-point, because the next video is on multi-point. That's the only difference you do. Only difference you make. You just change that from point to point to multi-point. So let's go ahead and just put point to point. Now we have a sub interface that's up. Let's look at our interfaces so far. Do show IP interface brief. And now you see we have a virtual interface, which is actually a sub interface. That's up. That appeared out of nowhere. It just popped up like, hey, I'm here. we are going to create a connection from that subinterface. Actually, we're going to give him an IP address, right? As you see right here. Here go the instructions in case. Yeah, that's your spoiler alert right there. So let's go ahead and give him an IP address. So IP address 10.1.1.1 255.255.255.252. Do you remember what the CIDR representation notation for that is? It's a slash. That's a slash 30. I had to think about that. That's a slash 30 CIDR notation. Frame relay. Now instead of, if you remember from the last video, we did I did the Migos and had y'all memorize the command to map an IP address to a DELC. We don't do that with subinterfaces. With subinterfaces, you do frame relay, interface DELC, and then you put the IP address. I mean the DELC. Notice DELCs are defined from 16 to 1007. Now there's different ones, like 0 to 16 I believe is reserved. I'll leave a link in the description on what the different numbers of DELCs are. In this case, we are putting DELC 102. Right, so far we've got 17% of this complete. Interface, now we're gonna create another sub interface. Let's get out of this guy. Let's do a copy run start, because God forbid something happen and we lose what we got so far, right? Interface serial 000.3. We're gonna create a point-to-point link. That's up now. Now do show IP interface brief so I can show y'all. We just created another sub interface. Now that's up. We need to give him an IP address as well. So now we're gonna have like it's like we created another link here. So now it's like we got two links to this router we gonna have. So now we gonna give him an IP address 10.1.3.2 255.255.255.252. You remember what that is in CIDR notation? /30, right? /30. Frame relay, interface DELC 103. So now we've got two sub interfaces. I'll show y'all. Do show IP interface brief. And now, let me show y'all real quick. We've got two sub interfaces that we created, and they both have IP addresses. What are their DELCs? How do we find that out? Exit. You get this done, Control Z. Show frame relay map. And now we've got our DELCs. We can see what IP addresses map to what DELC, plus whether they're active or not. Serial 000.2 is mapped to DELC 102. It's a point-to-point link, right? Broadcast status defined is active. You remember what the definitions were, right? Active indicates that the connection is active and that the routers can exchange data. Can we ping? I highly doubt it, because we haven't done the same thing to router 2 yet. But let's do it anyway, just to test our theory. We need to ping router 2. What's router 2's IP address? 30.1, right? Let's go ahead and see if we can ping him. Ping 192.168.30.1. Sending. It's not gonna work. We haven't done this. We have to do the same thing. We have to map an IP address to the sub interface, or we have to create sub interfaces on these guys, and then give them DELCs and map the IP address to that guy. Actually, we're not mapping IP addresses. We just creating a DELC for it. So notice it failed 0 out of 5. So we got to do the same thing on the other side. First, let's add some network entries to EIGRP Autonomous System 1 to reflect the IP addresses above. Now, this is why we create sub interfaces, because when we get EIGRP updates, the split horizon is going to prevent the updates coming back, right? Because they're coming out of the same interface. But since we created subinterfaces, we're going to be able to receive EIGR updates to the other routers. That's why we create subinterfaces. Let's go ahead and create some network entries for EIGRP. Configure terminal interface. Actually, router EIGRP 1. Network 10.1.1.0, 0.0.0.3. Remember, that's the wildcard mask of /30, really. So this is a wildcard mask. If y'all remember what that is, I don't think we went over that for this, but if you study in CCNP, you should know what a wildcard mask is by now. So we are at 26% complete. We need to create another network statement for the 10.1.3 network, which is the subinterface for 0.0.0.3. So we're going to send in EIGRP updates to that IP address for that interface. So network 10.1.3.0 wildcard 2 or 0.0.0.3. So we ain't gonna have no IP or EIGRP neighbors, but let's check anyway. Show IP, do show IP EIGRP neighbors. I said neg. You know what that is if you speak Creole. None. We have a process, but we don't have no neighbors yet. So now we got to configure router 2 to use subinterfaces. We're gonna do the same thing on this guy. It's just that we're gonna create the subinterfaces and their map, create their DLCs for them. So DLC 201 is gonna be used to communicate from router 2 to router 1. Let's do that. DLC 201. So we need to create a subinterface. We're gonna look at the address table to see what our IP addressing scheme is. Enable, configure, terminal, interface, serial, 0.0.0.1. What we put here, do you remember? Point to point, right? And then we need to do interface, we got to give him an IP address. That's this guy right here. 10.1.1.2 255.255.255.252. We're at 36% complete. Now what else we need to do? You remember? We need to create the DLC. Frame relay interface DLC. And then we put the DLC that we just mentioned before. DLC 201. So we're creating this DLC to communicate from router 2 to router 1. And notice the DLC is 201. They made it to make sense. 201. We're at 42% complete. So now we have a DLC to communicate from router 2 to router 1. Do you think we can ping now? Probably not. Well, we haven't. Why? Because we haven't created the network statement. But before we do that, let's go ahead and create the DLC from to communicate from router 2 to router 3. So we need to create a DLC from we need to create a subinterface to create from router 2 to router 3. Right? The other subinterface is router 2 10.1.2.1. So let's get out of this guy. Let's do a copy, run, start to save our work. Interface serial 0.0.0.0.3. Oh, cannot subinterface. You know why? Because we need to make it a point to point. So notice that mistake there. Point to point. Did you see that? Did you see that? He said he couldn't do that because this is already basically a point-to-point link. So the physical interface already has a point-to-point link. So you can't just create another one out of there. So we got to give him an IP address. So basically, this is what we're doing here. We're creating a subinterface to go from here to there. And we're going to give it a delcy to know that anytime we send traffic that way, it's going to router 3. IP address for router 2 is, or subinterface, the second subinterface is 10.1.2. So 10.1.2.1, 255.255.255.252. Boom. We're halfway done so far, y'all. We created an IP address. What else we need to do? Map the delcy. Frame relay interface delcy. What's the delcy from router 2 to router 3? Router 2 to router 3, delcy 203. Notice that delcy made sense. That's why they did that. Normally, these delcies are provided to you by your service provider. So far, we got 56 of this percent complete. So now we need to make some network statements. Now, these are not given to us here. We just need to know how to create our network statements. Hopefully, we know how to do that with EIGRP. But it says here, create appropriate EIGRP entries for router 2 for autonomous system 1. How do we do that? Let's get out of this guy. Router EIGRP 1, right? Network. What networks do we need to advertise EIGRP out of? These subinterfaces. So that's basically the 10.1.1 network and the 10.1.2 network. Let's do that. Let's see. 10.1.1, 0. And then this is a /30 network, right? What's the wildcard mask for that? 0.0.3. Boom. Now we got an EIGRP neighbor. Say that 3 times in a row. We got an EIGRP neighbor. Who is that guy? 10.1.1. That's our neighbor. Who is that guy? Let's look at our addressing table. 10.1.1 is a subinterface. It's a subinterface on router 1. So now router 1 is our neighbor using a subinterface. Y'all see that? Neighbor 10.1.1 out of that subinterface, not a physical interface or subinterface. So we basically created a virtual link here and created and made a neighbor here. EIGRP would work without this stuff if we were directly connected, but we're not. We are connected through a frame relay cloud. That's where these subinterfaces come in, because we're going to be receiving updates, EIGRP updates through our subinterfaces. Next network statement we need to create. Network, this guy right here, our next subinterface, 10.1.2. 10.1.2.0. We don't care about that last bit. So wildcard mask is 0.0.0.3, I believe. Yeah, of course it is. And the 10.1.2 network is from router 2. That's how we know, because of the delcy. Router 2 to router 3. Why haven't we created a neighbor yet? You know why? Think about that one. We haven't created those network statements on this guy, so we haven't made a neighbor yet. We haven't mapped any statements yet. We basically haven't configured router 3 yet. So next thing we need to do, we've got 64 of this complete. Let's run some show commands, see what we got so far. Do show frame relay map. Here's what we've got mapped so far. Serial 0001, 000.1. We've got a point-to-point link here. So this is basically saying this is point-to-point. It don't look like this right here, but it appears that way. It appears that way because of the delcy. It appears that we have this sort of connection, but we don't. We got a frame relay cloud between us. But that's what this gives it the illusion of. delcy 201, which is locally known to us. delcy 201 is locally known to router 2. Broadcast status active. Let's do a show. Let's get out of this. Show frame relay. What else we got here? Let's do show frame relay PVC. Again, del C 203, 201. Now we've created. We've got some BECN bits. None so far. Luckily, it's not. This basically is. These are just congestion. If we see any of this stuff having numbers on it, this is congestion. If you don't remember what those are, look in the last video. We need to configure router 3 with frame relay statements as well as our network statements. So router 3, we need to do this guy right here. Enable, configure, terminal, interface, serial, 000. What's the addressing table? 000 dot .1. Point to point, right? What are your options? That's only the difference between a point to point and multi-point. We talked about what the difference between point to point and multi-point was, right? The only difference is you only changing that command right there. So we might be able to knock out 2 videos in one with this. We'll see. So point to point. Now that interface is up. Let's go ahead and move on along because basically we're doing the same thing we did on routers 1 and router 2. So we got to give him an IP address and map del C to it. IP address 10.1.1 or 10.1.3.1 255.255.255.252. And also we need to create another subinterface frame relay. We need to map the del C interface del C. We need to do the del C from router 3 to router. Let's see, this guy is supposed to be, I believe, router 2. It's router 3. From router 3 to router 1 is del C 301. So we need to do del C 301. Boom. Let's do the other subinterface. Interface serial 000 dot, I believe it's 2. Yep. Dot 2. Point to point. Interface. Actually, we need to do IP. Give them an IP address. 10.1.2.2. 255.255.255.252. You remember what that is in CIDR notation? /30. Point-to-point links are usually /30 because we don't want to waste any IP address space. So that's why we do it at /30. We got 86% of this complete so far. We gave him an IP address, frame relay, interface, del C. We need to create a del C from router 3 to router 2. So I believe it's 302. We've got 92% of this complete so far. We need to create some networking statements and move along and get back to our studies. Network, actually router, EIGRP 1, network. What networks we need to create here? We need to advertise EIGRP out of. Look at this addressing table and pause which networks we need to create or we need to advertise EIGRP out of for router 3. That's right, the 10.1.3 network and the 10.1.2 network, right? Because we don't care about this last bit, 1 and the 2. Let's go ahead and do that. 10.1.3.0 and then the wildcard mask 000.3. Boom. We got an adjacency. Who we got an adjacency with? 10.1.3.2. Who is that guy? Router 1. So now router 3 has an adjacency with router 1. These guys have adjacencies. Let's see if the PC can ping the web server now that he has an adjacency. Let's just do that real quick. We're almost done here, y'all. I know this is probably the longest video I created so far. Ping web server is what? 209.165.200.2. 209.165.200.2. Pinging, pinging, Pinging. Timed out. Got a reply. Bruh, we just did it now. So we good so far. We almost done. We need to create a network statement for router 3 to, we need to advertise EIGRP out of router 3 to router 2. So now, notice these guys have an adjacency. So now when they receive updates, they're going to come out of one interface and out of another interface. So they'll be able to receive updates to each other. So let's, we got one more network statement to create. Network 10.1.2.2. I'm sorry, 2.0, right? The address is 2.2. It might be able to work, but we don't want to do that. We just want to create a network statement that cares about just these first 3 bits. So 10.1.2.0, 0.0.0.3 is the wildcard mask, .3, 100% complete. We have a neighbor adjacent EIGRP adjacency with 10.1.2.1. Who is that guy? 10.1.2.1. That's router 2. So now he has an EIGRP adjacency with that guy. Let's go ahead and see if the laptop can ping the web server now. Ping 209.168. I'm sorry, 165.200.2. Oh, we immediately got a reply. Bruh, we immediately got a reply. That was great, man. So yeah, that's the how you configure frame relay on a point-to-point subinterface. The only difference between point-to-point and multi-point is when you create the, I'll show y'all real quick. The only difference is you creating for a point-to-point link, you put this, create the subinterface, and you just put point-to-point here. On the multi-point link, you just put multi-point. If you notice right here, this guy has only one point-to-point link, right? 2.1.1.1, right? That's his point-to-point link. He's mapped to Del C20. That's one point-to-point link. So this guy right here, this is a point-to-point link. This is a point-to-multi-point link. The only difference is we create a sub-interface here, and he has multiple links on one sub-interface. That's the only difference. So we might be able to roll this all up in one video. I'll do a little bit more research. If you don't see, basically, if you don't see a multi-point video, now move on to the next topic, which is layer 3 technologies. Finally, this is 40% of the exam. Once we move on to that, if you don't see a video for multi-point, that means we roll both of these into one. So for now, if you like this video, comment, like, subscribe to the network.